All right, let's get right into it. The biggest thing happening in production AI today, it's not about bigger models or faster chips. It's about the fundamental architecture. We're seeing this massive shift away from simple straight lines or chains and into these complex, intelligent graphs. And this one change is completely rewriting the rules for how we make AI do real, useful work. In this quote right here, this is the core idea for this entire explainer. For the longest time, we kind of thought about AI tasks as a simple A to B to C process. But if you want to build something that's actually robust, something that can survive in the messy real world, you have to get on board with this new role. Production AI is a graph. It has loops, it has cycles, and crucially, it has the ability to think again. So, what does this big paradigm shift actually look like? Well, on the one hand, you've got the old way, the chain. It's linear, it's super brittle, and it pretty much only works on the happy path, where absolutely nothing goes wrong. On the other side, you've got where we're all headed, the graph. It's cyclic, it's resilient, and the most important part, it's self-correcting. Let's really dig into what that means. So first, let's talk about the problem we're all trying to solve. Back in 2023, most AI apps were built like simple chains. And the issue, as anyone who's ever written a line of code knows, is that the happy path is basically a fantasy. The real world is just messy. The logic of a chain is so simple, it's tempting. You have an input, it goes to step A, then to step B, then step C, and poof, you get an output. It looks so clean and perfect on a whiteboard. But what happens if an API times out at step B? The whole thing just dies. It's a house of cards. It's fragile by its very design. And this image shows the problem perfectly. The process kicks off, it does a search, and then it fails. That big red X, that's a full stop, a dead end. The process never even gets a chance to reach the book step. It's a total failure, and there's absolutely no way to recover. Okay, so how do we fix this fragile mess? Well, we move to the resilient graph. And this isn't just some small adjustment. It's a totally different way of thinking. It's built around these ideas of cycles and state machines. So let's just get our terms straight really quick. When we say graph, we're talking about a system of nodes and edges. Nodes are like actions, search for flights. Edges are the decisions that connect those actions. But the secret weapon, the real magic here, is the cycle, the loop. It's what gives the system the power to go back, resync, and try again. Now let's look at that exact same process, but rebuilt as a graph. It starts, it searches, but then it hits a validate step. If that validation fails, look at what happens. It doesn't just crash, no. Instead, an edge sends it right back in a loop to refine query. It gets a second chance to get it right. That is what resilience looks like. Okay, so this whole graph idea sounds cool in theory, right? But what does it actually look like in a real application? Well, we can see it in a pattern called REACT, which stands for Reason and Act. It's basically a framework that creates the core loop that lets a single AI agent think and fix its own mistake. So here's our scenario. A user types a very human, very vague request into the Skystream Airlines app. Fly to London next week for cheap. I mean, what is sometime next week? What is cheap? A simple chain-based system would probably just choke on that ambiguity and fail. So what does our graph-based agent do? First attempt, it searches for London Heathrow, LHR, and finds flights over $2,000. Ouch, that's definitely not cheap. A brittle chain would just stop right there and report failure. But our agent, it enters the cycle. It literally thinks again and realizes, hey, there are other airports in London. Second attempt, it searches Gatwick, LGW, and bam, it finds a flight for $450. Success. Now, what's so cool about this diagram is how it formalizes that whole process. The REACT loop is just thought, then action, then observation. The observation, hey, these flights are way too expensive, feeds directly back into a new thought. I should probably check some other airports. This simple loop is the fundamental building block of agent intelligence. Self-correction is incredibly powerful, but some problems are just too complex for one agent to handle. That's where we scare things up, from a single loop to a whole squad of collaborating agents. This multi-agent pattern is often built with frameworks like Microsoft's AutoGen, which basically lets agents with different jobs talk to each other to solve a problem. And that leads to a really crucial question. What happens when a problem isn't just about finding the right data, but about balancing different, maybe even conflicting points of view? A single agent can't be a lawyer, a customer service expert, and a manager all at the same time. So let's take a new scenario. A VIP customer at SkyStream is demanding a refund. This is a delicate situation, right? You need the hard legal facts, you need the business contacts about the customer, and you need someone to make an executive decision. This is a perfect job for a multi-agent squad. So, first, the graph sends the request over to Agent 1, the lawyer. Its only job is to analyze the terms and conditions. It's purely logical, no emotion, and it comes back with a really blunt answer. According to the contract, we don't owe them a thing. But, and this is so important, the graph doesn't just stop there. It takes the lawyer's input and routes it over to Agent 2, customer success. This agent has a totally different context. It knows this customer spends 50 grand a year with them. It argues that, yeah, the lawyer is technically right, but just saying no would be a terrible business decision. And finally, both of these conflicting inputs get passed to Agent 3, the manager. This agent's job is to be the decider. It weighs the legal risk against the business relationship and makes the final call. Issue a $200 voucher. It's a nuanced decision that a single agent would have really struggled to make. So the huge takeaway here is this idea of separation of concerns. As you can see in the diagram, each agent has a clearly defined specialized role. You don't want your lawyer agent trying to be empathetic, and you definitely don't want your customer success agent trying to write legal documents. The graph acts like an orchestra conductor, getting them all to work together to produce a much smarter result. So let's step back for a second. We've just built this incredible engine. It loops, it thinks, it self-corrects, and it even collaborates in a team. But all this new power creates a whole new set of challenges, and they all center on one single word: control. I mean, really think about it. We just celebrated how powerful the loop is, but what if it can't find a good answer and just keeps trying? Forever. An infinite loop. Or what if our lawyer agent and our customer success agent just can't agree? What if they get stuck in their own loop, passing the problem back and forth, arguing forever, and racking up thousands and thousands of dollars in API costs without ever solving anything? And here's the most chilling question of all. What if, in its brilliant attempt to self-correct a problem, the AI decides that the most logical and efficient solution is to delete the entire customer database? Without guardrails, self-correction can easily become self-destruction. Look, building these powerful, resilient graph-based systems is really only half the battle. The other half, the part we're going to cover next time, is all about installing the brakes. We're going to dive deep into the critical topics of safety, evaluation, and the guardrails that you absolutely need to keep these powerful engines on the track. See you then.